Hi, good morning. It's Gene from maverickstar Observatory. Guys, it's the 17th of April. As you know, on the 17th of April we do the latest magnetic pole migration position. And as you can see there on the chart, we have the longitude and latitude. For those that you like to mark it out on your own Google Earth maps, it's 83 degrees by 11 hours, 5 minutes, 93 seconds north. Longitude is 122 degrees, 57 hours, 14 minutes and 71 seconds east, which means the magnetic North Pole has migrated from last month 5.2 miles. That's a 20% increase. So what does this mean? Is things starting to pick up, or is it just a little blip in the road? Guys, we're only going to just have to wait and see, because obviously if we start to see an increase in the miles in which it's moving, then we'll know. Usually, as you guys know, if you're following, it moves around about 4.2 miles, sometimes 3.9 miles. So when it moves 5.2 miles extra on the month, you know, that's a significant change. It's a 20% increase on the speed. Let's have a look at where we're heading. Let's just zoom out so that we can see, you know, all the pins that we've recently put in, the direction of the magnetic North Pole and where it's moving in conjunction to 40 degrees. If I just zoom out, not too much, I want to be able to see it. If I just zoom out a little, you'll see how close we are to that theoretical 40 degree mark. Now, you can't hold me to it, guys. It's only based on some of the experiments. I'm going to recreate some of the experiments over the coming weeks so that you get to see why we believe when we get to the 40 degree mark there will be some significant changes in that the dipole, or the magnetic North Pole, will be entering the weak field lines from that point of 40 degrees. How long are we away from it? Just around about 2 years now. So it won't be long before we put this theory to test. And, you know, as the experiment showed, which I'll recreate again, like I said, next week for you, you know, when we leave the strong field lines, which is really what holds the magnetic North Pole in a position where it moves very slowly, like we've been seeing over the last few years, once it passes that point, things should speed up. And I know that this goes against a lot of the bigger organisations' ideas on this, because some are saying, you know, it will be 10,000 years before the magnetic poles reverse. It will be 1,000 years before the magnetic pole reverse. In fact, if you look at NOAA's plot and position for the magnetic North Poles, they only go up to around about 2015 with GPS coordinates, and so do NASA's. And the problem with this is that they both show at the same time different positions for the magnetic North Pole. It's like these organisations haven't got together and said, look, which one is right out of the two. So there's a bit of an anomaly there in the way in which they're working out the position of the magnetic North Pole. You would think the European Space Agency would be able to pinpoint it with 3 satellites specifically designed to manage the Earth's magnetic field. You think that they would be able to, you know, say this is where it is, and, you know, I think people would be interested in knowing that every month, but they don't. It seems like we're the only ones that have bespoke equipment that actually pinpoints the magnetic North Pole every month. And that's why I say, guys, you know, this observatory is unique in what we've got with the equipment that we've got. And we're small, you know, we're publicly funded. We don't raise a lot of money, but it's the skills that we've managed to learn along the way which has enabled us to build this equipment to do this and relate back to you guys. And, you know, you shouldn't take that for granted, because if anyone else was to try and replicate the technology that we've got, like the Trimag or the magnetosphere sensor or our magnetometers out there in the field, or even the muons, if they was to try and build an observatory to date like what we've got, it'd be in the tens, if not, well, it would be in the hundreds of thousands. Let's just not even beat around the bush. But look where we're heading. 40 degrees mark We're not too far away, 2 years away, in fact. If we just zoom in, is it by just coincidence that if you follow the mid-Atlantic ridge all the way up to the northern hemisphere, the 40-degree mark falls slap bang on it? And I've had a few people mention to me recently that there are more undersea active volcanoes which are showing signs, if not already in eruption, in this region. Is that just by coincidence, or is these things linked? Was our 40-degree mark by coincidence just landed on that ridge? I don't think so. I think all these components play a major part in Earth mechanics, and the more data that we collect, the more we learn about what's going on, we'll figure it out. But there are some dark areas at the moment, and you can see yourself where we are with regards to the 40-degree mark. I want to zoom out because I want to show you that corridor where that white and yellow line run, almost the point in Russia where the magnetic North Pole is heading, without any questions of a doubt. No one from any of the other organisations out there, the major players, would deny it. See where that white pin is? That is where the magnetic North Pole is heading right now, and we know that because we've looked at the intensity maps, and the intensity in Russia, in that region where our white pin is there, is the highest intensity over the northern hemisphere. It is because of that region that we're looking at that the magnetic North Pole started to migrate 100 odd years ago. And the reason why the magnetic North Pole's heading there is because of the high intensity of that region, which has been increasing over the last 100 years. And the reason why Canada is losing it, which if we go right back 100 odd years ago to 1890, something like that, was the first pin on there, or even before that, 1880, we'll see that over that period of time, the magnetic poles, where they used to be anchored, and for 780,000 years was always there, have started to migrate because the intensity of Canada is weakening. So, if we go back over the pins, over time, what we find is that from the 1900s to 1990, the magnetic North Pole migrated just 500 miles. But from 1990 to this present day, it has migrated 1,200 plus miles and continues to migrate. So there has been a major increase in speed over time, which means the magnetic North Pole is covering more distance, in short. I don't think that NASA, the European Space Agency, and NOAA quite know what really is going on. I think there's a big mystery, not just for those organisations, even for us, but I don't think they believe that we could be seeing something happen around the 40 degrees mark in a rapid pole shift at that point, which I put off 2 years away. Think about that. The other important thing to note is that since the 1990s, since that increase in speed that the magnetic North Pole has covered 1,200 miles, whereas the previous 90 years before that it only covered 500, we've noticed in those last 30 years, from this present time back to the 1990s, some major changes in our climate. It's by no coincidence either that if you go back over the last 3 solar cycles, you will notice that there has been some major changes with solar activity, in that the sun's solar activity with regards to sunspots and emissions of storms and things like that have been reduced dramatically, and over the last 3 solar cycles we can see that they have changed and reduced over that period of time. But what happens, what's if we ask the question, what happens because of the magnetic North Pole increasing, which is a sign that the magnetosphere is decreasing in strength? What happens when we have, coinciding with that, the solar cycle declining in sunspot numbers? Well, only one thing increases. As a result of the sun going into almost a stall or hibernation, like it has done for the last 33 years or the last 3 cycles, we have a collapse or a shrinkage of the heliosphere. That allows more cosmic rays into our solar system. If our primary field, the magnetosphere, weakens, which it has done clearly over that time period, to the point where it's accelerated the magnetic North Pole migration, what, if we ask the question, is the result of that? It is more cosmic rays inbound through our primary defense field, the magnetosphere. So if we ask if we're getting more cosmic rays because of the low solar output and a weakened magnetosphere, what are the consequences on our planet? Well, I don't need to answer that question because I think most of you know it already. Just look at the dramatic changes to our climate during that period of time. And I will just ask this question to you guys. Is that by coincidence? No. The chances of it being just a mere coincidence are so far away. So far away. This is all happening as a result of the magnetic poles migrating and an added interference by the sun's activity, which is an unfortunate synchronicity, which is setting up the same problems for our planet right now. And that is why our climate is out of sync. That's why we are getting these 100-year snaps of cold weather that we never experienced before. But we shouldn't just say, well, this is just magnetic pole and solar related, because if you go back into the historical record and look at historical temperatures, what we will find is that we should be in a glacial period right now, or moving in the direction of a glacial period right now, according to the historical records. So we couldn't really be in a worse situation at this point. We have a sun in a low solar output causing cosmic rays. We have a magnetic pole reversal taking place, causing an increase in cosmic radiation, which is changing the climate because of cloud seeding. Look at the jet streams over the last 30 years. Where are the climatologists? And why aren't they asking the questions? Why is it a noticeable change over the last 30 years? What's happened to our planet's, climate? Why haven't they came out and said nothing? It worries me because I don't want to go down the line of conspiracy and accuse these organisations of knowing something that is coming down the line. But, when I don't see climatologists screaming about the fact that there's been such dramatic changes over the last 30 years, and I don't see these organisations coming out with anything more than level 2 magnetic information, I think we have identified the white elephant in the room quite clearly. Is no longer invisible. We know what's happening to our planet and why. And if the changes that have taken place over the last 30 years are significant enough to have caused all these problems, which I think you would definitely agree with me are the reasons, then just think what will happen when we hit 40 degrees mark in just 2 years, because everything points to an acceleration of events. It's worth giving that some thought. Guys, we're facing critical times at this observatory with regards to funding, and I hate having to even ask, but as the person that runs this observatory, we need funding for it. And if we don't get that funding, we simply can't deliver what we've been delivering to this point in time. And I think you would definitely agree to me that what we've done so far is beyond an ordinary human effort. There has been a massive effort put in here. Honestly, a lot of people wouldn't even imagine, but there has. The only way we can continue sustaining what we've got to this point is by increasing the funding, and it needs to increase a lot more than what it has, because we're at critical levels now with this observatory. You know, we're not out to make millions of pounds, we're just out to inform people, keep them up to date with what's going on with just really one topic. We do divert sometimes, but it's mainly about one topic. One topic which you should know is the most important. Because this one, last time it happened was 785,000 years ago, and humans have only been on this planet 42,000 years, and there is no way we could know what was going on that length of time ago, because we wasn't even here. So, you know, I'm going to mention the link. Please consider stepping up to the line and helping us at the observatory keep going. Links down there. Guys, have a great day. As always, bye for now.